Hello, and welcome to Chapter 2. This one's all about functions and graphs, and the 2.1 is actually just graphing. So you should have your 2.1 notes out in front of you and ready to go. Don't forget to post questions on the discussion board, and let's go. All right, graphing, we're going to talk about domain and range. We are going to go through, let's see if I can get my pens going here. Sorry about that. So we got domain and range. I want to know if a relation is a function or not. Doesn't mean it's not a relation, just I want to know if the relation is a function. I want to know what the equation is. I want to evaluate, so plug in points. I want to graph by plotting points. I want to use a vertical line test. Remember, if it passes a vertical line test, it's a function. I'm going to look at a graph and determine things about a function. I'm going to worry about domain and range a lot today. And then identify intercepts, so the x-intercept and the y-intercept. So let's keep moving here. So now when you're going through, the relation is any set of ordered pairs. So it's anything. It can be like this down here is a relation. It can be something that's represented by a relation, like y equals 3x plus 7. That's a relation because this represents ordered pairs. All right, the domain is all the first components of the ordered pair. So what does x equal? And the range is the second component, or what does y equal? So looking at your ordered pairs down here, I would like you to list the domain and the range. So pause and give it a shot. So domain, it's always in brackets because it is a set. It's the 5, the 6.1, 7.2, and the 8. The range is the y values, also in braces because it is a set. So 3.4, comma, 2.3, 1.2, and 0.1 should have been your answer. Now let's go on and look at, a function. That means that each element of the domain corresponds to exactly one element in the range. So each element of the x corresponds to exactly one element in the y. That means every x is different. So if you look here, all the following relations are functions, yes or no. So I look, are all the x's different? If all the x's are different, the answer is yes. And it's because it's going to pass the vertical line test if I graph this. So yes, all x's have one y is what you would say. Here, you would look at and you would go, no, you have 2 5s. So the answer is no. And technically is 5 maps is the word you would use to 9 and 8. So it's no because 5 has 2 answers. It has a 9 and an 8 when you go through them. All right, determine whether an equation represents a function or not. That means every x I plug in can only give me one y value. So if we plug 1 in here for x, so now I've got y equals plus or minus the square root of 1. Well, that would mean y could equal a positive 1, because the square root of 1 is 1, or y could equal a negative 1. So this is not a function because 1 for x maps to 1 and 1 for x maps to negative 1. So the answer is no. Okay, try yours. Your first step should have been to solve for y. So you have y squared equals negative x squared plus 1. You took the square root, but when you take the square root, you have to put the plus or minus in front. Now, when I plug in values for x here, I'm going to get two y values, a positive and a negative. So the answer is no. I'm hoping you recognize that that's actually a circle with a radius of 1. So it would look like this. And then remember the vertical line test from a long time ago? If you can draw a vertical line and it hits the function in 2 places, 2 or more places, then the answer is not a function because x has 2 values here. Evaluate means I'm asking you to take out the x and plug in what it is worth. So here I'm giving you a function and I'm saying evaluate at f of 2. So f of 2, I replace the x with 2, so I replace all the x's with 2. You're using substitution and calculating. Your turn. All right, so you're finding f of -5, which means you took -5 and you squared it. I hope you remembered your parentheses. Minus 2 times -5 plus 7. So you have 25 positive plus 10 plus 7, which is equal to, what's that, 35, 42. I hope you did a good job. And you're doing all the things you need to. All right, technically this here is a point because the x value is -5 and the y value is 42. So the value is at -5 of this function, y equals 42. So if I were going to graph this, I would go to -5 on x and 42 on y, and that would be the point of this graph. Okay, I truly hope you remember your parent graphs and you do not have to use these points. You should remember what an x cubed looks like and what the -1 does to it. But let's say you didn't. So we'd have -2, -1, 0, 1, 2. Okay, when you plug this in, -2 cubed minus 1 is going to give you -9. So you would go to -2, -9, and graph your point. Then you would do -1. -1 minus 1 is -2. -1, -2. I think my point just disappeared on me. Okay, this I'm not sure why that's happening. All right, 0 is going to give you -1. 1, so 1 minus 1 is going to give you 0. What is going on? 2 cubed is 8 minus 1, so that's going to be 7, and they all just disappear. I do not know why they're disappearing. Let's see if we can put these back in. -2, -9. -1, -2. 0, -1. 1, 0, 2, 7. And there they went again. I have no idea what's happening. And that would be your point. What you should remember is that x cubed is truly this graph. Let's try it. Here we go. So x cubed is the one that goes through 0, 0, then it's the S shape. It goes through 1, 1, and -1, 1. Then it goes like this, right? Okay. And then when the -1 is added, that moves the whole thing down 1. So you move every point down 1, and that's your new graph, the green graph. Kind of stayed for you. So now here, what does -x cubed plus 2 do? If you remember, you could graph it direct. You would say, okay, -x cubed is going to flip it. So instead of going up 1 over 1, it's going to go up 1 down 1 in opposite direction here. And then the 2 is going to move it up 2. So it's going to start at 2. This is my starting point. And then instead of going up 1 to the right 1, it's going to go down 1 to the right down 1. I don't know why this does not want to draw. Then up 1 down 1. So then it's going to look like, oh, there it kind of went. So, and that's what your new graph would look like. Okay, without that, you would plug in your points. So -2 cubed would be -8, but that's minus a -8, plus 2, which equals 10. -1 cubed would be -1, but it's minus a -1, plus 2, so that would be 3. So you would have -1, 3, which is right there. You would have -2, 10, which is right there. 0 would be 2, so 0 is at 2. 1 be -1 plus 2, and that would give you 1, which is, so 1, 1, which is where we're at. And then plug in your 2, be -8 plus 2, which is -6. So I got that one off a little bit. He should have been way down here. Okay, I hope you did a good job. I do not know why this is not graphing right now. We'll have to play with that a little more. Hopefully it gets better. Vertical line test means once you have a function, if you can draw any vertical line and it only crosses the graph once, no matter where you draw it, it is a function. So this is good. No matter where I draw my vertical line, it only hits the graph once. Here, I know I can draw one like on the y-axis and it crosses once, but I can draw one anywhere over here and it crosses twice. It only takes one vertical line to make it not a function. So up here on your x cubed graphs, let's try this out here. Is this a function or not? And the answer is yes, because all the vertical lines only hit the graph once. Okay, let's continue. All right, we are looking here now. I'm just wanting to know if you can read a graph. It says find f of 5. Well, 5 is always the x value, or this value here. So you go to f of 5. So right here is 5. F of 5 is what does y equal? Because that remembers f of 5 means y, and y equals 400. Okay, try yours now. F of x equals 100. So this time I'm giving you 100, and I want to know what the y value is, and I got not, or the x value, I'm sorry. So x equals 9. And this in here is y equals 400. Nothing too complicated here. Domain of a function from its graph, and then you have to look at its points. Now remember, domain is all the x's, range is all the y's. So when I say what's the domain, I'm looking from where does this graph start on the x-axis to where does this graph end, but on the x-axis. So I'm looking from here to here. So the domain goes from, and that's closed dots, so it's a bracket, -2 to 1. Oh, that's a positive 1. I don't know why I wrote that. All right, and since it is a closed dot, it is a bracket. Your range is your y value. So now you're looking, where does this graph start on the y? So it starts here and it ends here. So you're looking at this y value. What is it between? And the answer is 0 to 3. And it's inclusive again because of the brackets are the closed circle. So 0 to 3, inclusive is the range. All right, that usually gets messed up, so be careful. Try yours. And please truly try it. So here, the domain starts here, but look, it's an open circle, and it ends here. So I'm looking at this x value. So the x value goes from -2, but it's open, so it does not include it. So that's a parenthesis to a +1, and that's a bracket. Now the range is the y value, so you look at where it starts on the y, so you go up bottom to top. So it starts at -1 and it goes to 2, but 2 is the open circle again. So I'm going to start at -1, I'm going to end at 2, and 2 is not inclusive. Intercepts. I hope you know this, so try them. X-intercepts are actually the red dots on this one. Where does it cross the x-axis? So you should have, and they had write them in points. -3, 0, -1, 0, 2, 0. Y-intercept is where does it cross the y? And that's the blue dot, which is oh, sorry. I would have yelled at you for that, so don't you guys do that. 0 to -6, make sure the y has the value. And that's homework time. I hope you did a good job, and remember to post on your discussion board.